Hello everyone and welcome to AWS Tech Talk on building a data mesh architecture with Amazon Athena. I am Saurabh Bhutiani, Principal Analytics Specialist Solutions Architect with Amazon Web Services. Let's look at the agenda for today. First, we will go into what it takes to become a data-driven organization. Then we will look at various concepts, data lake, modern data strategy, and understand data mesh. We will then see how to create a data product and data mesh with common architecture patterns. Then we will dive into Amazon Athena and Athena data connectors. We will see how to orchestrate Amazon Athena ETL workloads. And finally, we will see how Athena helps in realizing the data mesh architecture. Let's look at how to become a data-driven organization. First, companies are really struggling with getting value from their data and evolving to a data-driven organization. A recent Forbes article suggests that 99% of businesses want to become data driven, but only 24% have been successful. Why is that? Smaller organizations might be able to get away with one centralized data lake when teams are small and work closely together. However, as organizations grow, so does their data across data lakes, and data might end up in silos because central data lake or data platform teams are not able to scale the way each individual business units are scaling. That makes data sharing challenging. There are common barriers to driving business outcomes with data, and they include support for collaborative model of data producers and consumers, data as a platform versus data as a product. Companies tend to focus on collecting and storing their data as a platform rather than focusing on how they are going to use it as a data product. Integrating data governance and compliance across the organization, enabling common access across the enterprise, and ensuring trust and confidence in the data. Companies don't lack data. They struggle with transparency of information assets across the company and tying data to specific value or business outcome. Here are some examples of things we hear from our customers. Do any of these resonate with you? Customers who are successful as data-driven organizations treat data as a product, collaborate and share data across the enterprise to drive business impact, and provide a federated data governance and compliance model between producers and consumers. Not all governance strategies can be based on a one-size-fits-all model in a complex business. So let's talk at a high level about why this need for a data mesh came about. Data mesh is not the solution for every company. It is an appropriate strategy for businesses with complex application landscapes driven by business units separated by regulatory, legal, geography, or product-oriented considerations. Here are some of the characteristics that may warrant a data mesh strategy. Mature, decentralized business with significant investment in data that is organized in silos today. Business grown through heavy acquisition. Businesses who want to unlock innovation across these diverse business units. Companies who need decentralized governance but also need enterprise-wide transparency. The overall challenge is leveraging data as an asset across the enterprise to drive business outcomes with agility, transparency, and cost effectiveness. Consider an example of an insurance company with completely separate business units for property and casualty, home and car insurance, who wants to cross-sell to their customers who has grown these capabilities through acquisition. In this situation, it is common to see completely disconnected data lakes environments for each of these areas of the business. This makes it increasingly difficult to create a strategy where they can use data from across the whole enterprise for a cross-sell use case. First, most companies think of their data as a platform, not as a product. So let's start with the concept of data as a product. A data product is simply a broad, cohesive collection of related data, analytics, ML capabilities, etc., aligned to a specific use case and or goal. For example, this might be a customer 360 capability, which could incorporate data from across multiple lines of businesses and different business units to create a clear picture of a customer across the enterprise. This data product is intended to enable or drive a defined, well understood, quantified business outcome. As a modern data architecture, the approach is not just about integrating your data lake and your data warehouse, it's also about connecting your data lake, your data warehouse, and all your other purpose built services into a coherent whole. The data lake allows you to have a single place so that you can run analytics across most of your data, while the purpose built analytics services provide the speed you need for specific use cases like real time dashboards and log analytics. This modern data architecture consists of following key elements. A scalable data lake. It starts with Amazon S3. Customers have been building data lakes on S3 longer than any other cloud provider, and today more data lakes run on AWS than anywhere else. They can use Athena, an interactive query service, to analyze all of their data. In addition to the data lake, customers use a combination of our purpose-built database and analytics services like EMR, Amazon OpenSearch, and Redshift to ensure they are using the right tool for the job to get the high performance and scale at the lowest possible cost. To move their data between these systems, they use AWS Glue, our serverless data integration service. For unified governance, they can use AWS Lake Formation to manage the security and governance of all of their data in the data lakes. And finally, in all of these cases, we have invested heavily in offering the best price performance out there. So, how does all of this relate to data mesh? In an organization, you might have multiple data lakes or modern data architectures. We can also call these data domains, each making their data available as a product to other parts of the organization. And we would like to tie all of this together. So in our previous example related to insurance products, we might have a lakehouse specifically for the property and casualty business unit and a separate lakehouse for the home insurance business unit. So now let's put these concepts together to create a data mesh. A data mesh is a pattern for organizing around one or more data domains, modern data architectures or lakehouses to deliver enterprise data products. Supporting data producers and consumers from across the enterprise with a layer of federated governance through a lightweight policy in the middle. In order to decentralize the monolithic data platform, we need to reverse how we think about data, its locality, and ownership. Instead of flowing the data from domains into a centrally owned data lake or platform, domains need to host and serve their domain datasets in an easily consumable way. Another way to say is that a data mesh is an effective way to combine multiple data lakes built with modern data architecture in a decentralized manner. Combining data lakes across a mesh, each of these modern data lakes offers its own data product. They become data producer, and those in the organization using that data become data consumers. Producers can be consumers and consumers can be producers. Producers have domain expertise. They are experts within their area. They can collect, curate it, and make it available to someone that simply needs to consume it. An example could be a sales organization that generates sales data as a producer and share that with a marketing organization. At the same time, the marketing team could produce marketing related data and share that with the sales organization. To summarize, we can say that data mesh is a pattern of defining how to organize around one or more data domains with a focus on delivering discoverable, trustworthy, understandable, and secure data products. So at a high level, you can think of a data mesh as a collection of domain-specific data lakes built with modern data architecture that unlock enterprise data products, provide lightweight federated governance, and empower self-service data sharing. A data mesh is not a centralized data store, but an enterprise view across all the distributed data within a complex organization. So let's go back to our example. The data mesh would now provide transparency across the previously siloed data for property and casualty, home and car insurance. Each business unit could enforce the specific governance rules for their own business unit, but provide the necessary access to enable a customer 360-degree data product. This would allow them to provide a more comprehensive customer experience and to cross-sell products from across the enterprise, which could not only benefit the bottom line of the company, but benefit the customer by reducing frustration and reducing their overall spend on insurance related products. So who can benefit from a data mesh? Those that can benefit typically see one or more of the following: have a well-established data strategy and have successfully implemented it, have a current implementation of a modern data architecture or a lakehouse, have decoupled business units that operate autonomously in data domains. There is a need to share data across business units or with external partners, require consistent data governance across multiple teams which are not part of a single organization. Let's look at two typical patterns of a data mesh. Data mesh patterns are still emerging, and these are the two that we are seeing from our customers. The first pattern we will look at is the hub and spoke pattern. In this pattern, each producer shares directly with the consumers as needed. Notice how each of the boxes representing the producers or consumers have the modern data architecture. This does not mean they all use the same services. The entire point of this decentralized approach is that each data domain or consumer can choose the services they need or prefer. In other words, consumers don't have to worry about how the producer creates the data. They just need to care that they get what they expect and consume it using the tools that they prefer. From a governance perspective, the producers own the data and solely decide who they want to share with and what they want to share. There is no central data catalog in this pattern where consumers can go and search for data. Consumers would need to know who to ask for certain data and request access directly with the producer. Note again that each of these consumers can also be producers. This here shows one data domain sharing with 4 consumers. The hub and spoke pattern is the simplest data mesh pattern of the two we are looking at today. Let's look at a more advanced version. The centralized governance data mesh pattern is centered around a central governance account. This central account contains a central data catalog that holds metadata for all producer accounts. This pattern comes with additional benefits such as central auditing of data catalog, grants, and activity, making this a better choice for very large enterprises or highly regulated industries like financials, healthcare, or government, as mentioned earlier. Producers still have their own data lakes for their own data domain. Producers also retain full ownership of the underlying data in their data lake, just like before. They can then add new databases and tables to the central data catalog, and they can make changes to the metadata whenever needed. Consumers can explore the metadata in the central data catalog, but they only see the metadata of databases or tables that producers decide to share. They can search for datasets that they need and request access to that data. Central policies can be applied as needed. For instance, a producer has shared metadata that indicates that a dataset has PII in it. As data is shared from the central catalog, PII data can be filtered such that consumer is only granted access to non-PII data. This can be done with the hub and spoke model as well, but in that case, it's up to each producer to track and central auditing becomes more complex. Once a request for access to producer data has been approved, access is granted via the central data catalog and data will be accessible in the consumer account. From that point, the process of using the data is similar to the hub and spoke pattern. Let's look at what Amazon Athena is and what it provides. Amazon Athena is serverless. You can query your data without having to set up and manage any servers or data warehouses. Just point to your data in Amazon S3, define the schema, and start querying using the built-in query editor. With Amazon Athena, you pay only for the queries that you run. You can save from 30 to 90% per query and get better performance by compressing, partitioning, and converting your data into columnar formats. Amazon Athena is open and flexible. You can use SQL to query, and we support Parquet, CSV, JSON, Avro, and other standard data formats and compression algorithms. We also provide JDBC and ODBC drivers to connect to your favorite SQL clients. And most importantly, Amazon Athena is easy. It's totally serverless, zero infrastructure to manage. There is zero administration, and you can use Athena from your favorite BI tools like QuickSight and Tableau. Athena's pricing is simple. You are charged only for the queries you run, and it charges $5 per terabyte of compressed data. DDL operations are free, query concurrency is free, data connectors are free to use. Other standard charges for S3 get, list, put, etc. would still apply. When we launched Amazon Athena, our mission was to make it simple to query data stored in S3 data lakes. Customers love how easy it is to do that, but told us they wanted to use Athena to join their S3 data with data stored elsewhere. That's why in 2019 we added connectors to sources like DynamoDB and Redshift. And with these data connectors, we expand access to data and give users the power to run SQL queries on data stored on-prem or in cloud and join it with data setting in S3. We made significant expansion of the sources you can query with Athena, and now you can query over 25 sources. We offer connectors to a number of AWS databases, including Redshift and DynamoDB, which are the two of our most popular sources. There are 10 plus connectors to third-party category. Many like SQL Server and Oracle are available on AWS, but you can also connect to on-premises instances. Setup is easy with our new Amazon Athena console. These connectors are open source. If you want to dig into the source code, you can check it on the GitHub repository. Let's look at what are federated data source connectors and how federated queries work in Athena. Federated query is a feature that enables data analysts, engineers, and data scientists to execute SQL queries across data stored in relational, non-relational, object, and custom data sources. Athena executes federated queries using connectors that run on AWS Lambda. AWS has created open source connectors for data sources such as Apache HBase, Redshift, MySQL, and Postgres, Redis, and also for services like CloudWatch. Data sources can be databases and services running in AWS, on-premises, or publicly available APIs. Using the Query Federation SDK, customers can build connectors to any proprietary data source. Because connectors run as Lambda functions, customers continue to benefit from Athena's serverless architecture and do not have to manage the infrastructure or scale for peak demands. So how does Amazon Athena Federated Query work? Athena invokes the connector function to list the schemas, databases, and tables. For example, when you browse the connectors catalog in the Athena console. During query planning, Athena invokes the connectors to retrieve partitions and splits. A subset of the partition that can be processed in parallel is a split. During query execution, Athena invokes the connector to retrieve the records of each split. If the connector needs to return more data than lambda 6 MB limit, it writes it to an S3 bucket instead with optional encryption. The connector performs the table scan phase of the query execution. Either that is, it loads the raw data from the federated data source. Athena pushes down some predicates into the connector, but not aggregates or limits. The connector function is the only thing that interacts with the federated data source. The federated data source can be anything at all, a relational database on AWS or on premises, a non-relational database, an API, or the result of a computation run by the Lambda function. The AWS step functions integration with Amazon Athena enables you to use step functions to start and stop query execution and get query results. Using step functions, you can run ad hoc or scheduled data queries and retrieve results targeting your S3 data lakes. To integrate AWS step functions with Amazon Athena, you use the provided Athena service integration APIs. Athena console provides step functions templates for common use cases, but you are free to create your own state machines with step functions for your specific use cases. Athena Federated Query can also be used for lightweight ETL workflows to extract and enrich data from federated data sources into S3 using create table as or in short CTAS or unload commands. Let's look at how to implement a data mesh pattern in AWS with Amazon Athena. You can implement this architecture using AWS Lake Formation cross-account access feature. In the producer account, there are two data sets called sales and opportunities in European Union or EU account. Lake Formation admin in producer account will grant permission to consumer account to access these data sets instead of duplicating the data. On the other hand, Lake Formation admin in consumer account creates the soft links to the shared resources and gives them unique names, EU underscore sales and EU underscore opportunities, and grants access to Amazon Athena. Consumers use Amazon Athena for consuming the data in the consumer account. With this approach, both producer and consumer do not have to depend on central IT to manage single monolithic data lake and can scale independently. Let's look at another data mesh pattern with Amazon Athena. In this case, the producer account has data in various data sources like Amazon Redshift and Amazon RDS database. To create a data product, producer admin uses Amazon Athena data connectors to first bring the data from these various data sources in Amazon S3 data lake and catalog the data with Glue data catalog. Once the data is cataloged, lake formation admin in producer account will grant permission to consumer account to access these datasets instead of duplicating the data. On the other hand, lake formation admin in consumer account creates the soft links to the shared resources and gives them unique names, EU underscore sales, EU underscore opportunities, and EU underscore orders, and grants access to Amazon Athena to these datasets. Consumers then use Amazon Athena for consuming the data as we saw in the previous pattern. So in the previous pattern, we saw how Amazon Athena helps on the consumption side in the data mesh, but in this pattern, we see that Amazon Athena can be part of both the producer and consumers in creating and realizing a data mesh pattern. Because of these customer needs, like unlocking the value of data using S3 as data lake, operational efficiency, speed, agility and innovation, and cost optimization, we have seen a larger push towards containers and serverless. By letting AWS handle infrastructure and operational burden and providing automation, customers are able to reduce the risk and focus on building business logic instead of infrastructure. By moving to a controlled and repeatable environment and embracing automation, we see product delivery velocity dramatically increase while improving quality, stability, and security. JP Morgan Chase implemented a data mesh in AWS, and here are their requirements and guiding principles. Their modern data platform approach required evolving monolithic data lakes to loosely coupled architecture, using distributed data pipelines, governance and compliance, and embracing data products. Their guiding principles were that they wanted to make data easy to share across the organization while maintaining appropriate control over it. JP Morgan Chase Bank took a two-pronged approach to address this. Firstly, by defining data products, which are curated by people who understand the data and its management requirements, permissible uses, and limitations. And secondly, by implementing a data mesh architecture, which allows them to align their data technology to those data products. This combined approach helped them achieve the following: empower data product owners to make management and use decisions for their data, enforce those decisions by sharing data rather than copying it, and provides clear visibility of where data is being shared across the enterprise. So to conclude, a modern data architecture serves as a blueprint for implementing data domains and creating data products in an organization. A data lake is a modern architecture used by many organizations and is also the starting step. A data mesh is a distributed data lake that supports self-service data infrastructure. You can use various resources to learn more about building data mesh in AWS. Thanks everyone for joining today for this AWS Tech Talk on building data mesh with Amazon Athena.